Hello everyone! Today we are going to make 5 degrees of freedom robotic arm which is capable of moving in the X, Y and Z axes. The gripper at its end can rotate from 0 degrees to 180 degrees. In this video, we are going to show you how to make the robotic arm, make its circuit, calibrate it and program it to control it using the keyboard. To make the robotic arm, you will need 3 metal servos, 2 micro servos with their accessories, some acrylic parts, nuts and bolts, spacers, few jumper cables, cable ties and a screwdriver. All these components are available in the robotic arm kit. You will find its link in the description box. Take the inner bearing disc and mount the servo horn on it using the self-threading M2 screws found in the metal servo accessories. Use the 4 holes which are closer to the center. Make an 80mm custom standoff using 2 30mm male to female standoffs and 1 20mm female to female standoff. Similarly, make 3 more. Fasten these standoffs to the inner bearing disc using M3 bolts of 8mm length. Make sure that you attach these standoffs on the side opposite to that of the servo horn. Take the base servo motor plate and attach the metal servo to it using M4 bolts of 16mm length and M4 nuts. Make sure that the servo shaft is at the center of the plate. Now we need to set the servo angle to 90 degrees. For that, first connect the metal servo to Evive servo channel S1. Then connect the adapter and switch on Evive. Set VVR to 6 volts by rotating the VVR knob. To set the angle, open Evive's menu and select Controls, then Servos, then Servo 1. Rotate the potentiometer 1 of Evive and set the servo angle to 90 degrees. Next, sandwich the bottom outer bearing disc, bearing to middle outer bearing discs, top outer bearing disc and the base servo motor plate together. Align the holes of the outer rings and hold them in place using 4 M4 bolts of 25mm length and M4 nuts. Finally, lock the servo horn to the servo shaft using the servo screw. Make sure that the standoffs are aligned to the outer bearing bolts. Now, take the robotic arm base and mount the other end of the standoffs to it using M3 bolts of 8mm length. Make sure that the base is mounted in such a way that the servo is closer to the rear end of the base. Take one of the side servo mounting plate and mount another metal servo to it using M4 bolts of 16mm length and M4 nuts. Make sure that the servo shaft is nearer to the end. Set the servo angle to 45 degrees as done before using Evive's firmware. Next, take the left lower arm and attach the servo horn to it using self-threading screws. Align and place the servo horn on the metal servo shaft and fix it using the servo screw. Make two custom standoffs of 60 mm length by attaching male to female standoffs and female to female standoffs of 30 mm length each and mount them on the left side servo mounting plate using M3 bolts of 8 mm. These standoffs will be on the same side as the left lower arm. Now mount the left side servo mounting plate to the left side of the base servo motor plate using M3 bolts of length 12 mm and M3 nuts. Next, take the left middle arm and attach it to the left side servo mounting plate using M4 bolt of 16 mm length and M4 nut. Keep it loose enough for the arm to rotate freely. Next, take the triangular junction plate and mount the other end of the left middle arm to it using M4 bolt of 16 mm length and M4 nut. Keep it loose enough for the arm to rotate freely. Now, take another left lower arm and mount it to the first left lower arm using M4 bolts of 25 mm length and M4 nuts. Add two spacers in between the arms to maintain a 10 mm distance. Next, take the 3D printed spacer and insert it in between the left lower arms. Take the two right upper arms. Next, bring together the triangular junction plate center hole, left lower arm stop hole, spacer, first right upper arm second hole, left lower arm stop hole, second right upper arm second hole, and fasten them together. Keep it loose enough for the arms to rotate freely. Now, take the right side servo mounting plate and attach another metal servo on it using M4 bolts of 16 mm length and M4 nuts. Set the servo angle to 90 degrees using Evives firmware. Make sure that the servo shaft is closer to the rear end. Next, take the right lower arm and attach the metal horn to it using servo screws. Then, attach the servo horn to the servo shaft using the servo screw. Next, fasten the right side servo mounting plate to the base servo mount plate using M3 bolts of 12 mm length and M3 nuts. Then, attach the side servo mounting plate to the 60 mm length standoff using M3 bolts of 8 mm length. Next, fix the two right upper arms together with a spacer sandwiched in between using M4 bolts of 25 mm length and M4 nut. Now, take the right middle arm and fasten it to the right lower arm using M4 bolt of 16 mm length and M4 nut on one side. Then, attach the other end of the right middle arm to the right upper arm using M4 bolt of 40 mm length and M4 nut. Add 3 spacers in between to maintain a proper distance. Keep it loose enough for the arms to rotate freely. Attach the left upper arm to the third hole to the triangular junction plate using M4 bolt of 16 mm length and M4 nut. Again, keep it loose enough for the arms to rotate freely. Next, take the end effector rotational micro servo plate and attach a micro servo to it using M2 bolts of 12 mm length and M2 nuts. Set the servo angle to 90 degrees using Evives firmware. Mount the rotational servo plate to the left upper arm using an M4 bolt of 16 mm length and M4 nut. Fix the end effector rotational micro servo plate inside the rectangular slot of the rotational servo plate. Make sure that the servo head faces downwards. Take another rotational servo plate and attach it to the other side of the end effector rotational micro servo plate using M4 bolts of 30 mm length and M4 nuts. Insert a spacer between the two right upper arms. Keep it loose enough for the arm to rotate freely. Next, take gripper part 1 and insert the micro servo in the slot on it and fasten it using M2 bolts of 12 mm length and M2 nuts. Set the servo angle to 30 degrees using Evive's firmware. Attach two M3 standoff of 15 mm length to the gripper plate 1 using M3 bolts of 8 mm length. Take gripper claw 1 and gripper claw 2 and attach them to the gripper plate 1 using M4 bolts of 16 mm length and M4 nuts. Make sure that the gripper claw 1 is near to the servo shaft and the gears of the claw perfectly fit together and are symmetric. Keep the bolts loose. Now, take the gripper link and attach a micro servo single-sided horn to it using servo screws. Keep it loose enough so that they can rotate freely. Take the gripper claw 1 and attach the other end of the gripper link to it using an M3 bolt of 12 mm length and M3 nut. Keep it loose enough for the claw to rotate freely. Open the gripper claw and then fix the micro servo horn to the micro servo's shaft. Finally, mount the servo screw on the servo horn to secure it. Now, take a gripper plate and attach a dual-sided micro servo horn to it using self-threading screws. Fix the servo horn to the rotational servo's shaft using a servo screw. Make sure the gripper plate is perpendicular to the micro servo. Finally, take the gripper assembly and fix it on the gripper plate. On the other side of the gripper plate, attach the gripper part 2 such that the standoffs align to the holes and fix it using M3 nuts. With this, the assembly of the robotic arm is complete. In case any of the M4 nuts come out or become loose during the assembly, use M4 lock nuts in their place at the joints. Now, let's move on to the circuitry. We are going to use Evive as the brain to control our robotic arm. First, let's connect the base servo. Extend the wires and connect the VCC and ground of the servo to the breadboard and signal pin to digital pin 2. We will be making the VCC and ground of all the servos common by connecting them on the breadboard. Now, take the link 1 servo, extend its wire and connect the VCC and ground in the same column as that of the base servo and the signal pin to digital pin 3. Third is the link 2 servo. Extend its wire to and connect its VCC and ground to the breadboard and signal pin to digital pin 4. Now, extend the wires of the rotational servo connect its VCC to +5 volt and ground to ground of Evive and the signal pin to digital pin 5 of Evive. Finally, let's connect the gripper servo. Extend its wire and connect its VCC to +5 volt of Evive, ground to ground of Evive and the signal pin to digital pin 6 of Evive. Now, Connect the positive terminal of the VVR pin to the VCC column and the negative terminal to the ground column. The complete circuit will look like this. Now, it's time to power up the Evive. Connect the 12-volt adapter to Evive and switch Evive on by sliding the power switch to external. Then, set the VCC to 6 volt by rotating the VVR knob, as higher voltage may damage your servo. With this, the connections are complete. Time to calibrate it. We are going to use PictoBlocks for the same. Open PictoBlocks. Connect Evive to the computer using the USB cable. Click on the board and select Evive and then select the appropriate port. Now click on the Add Extension button and add the robotic arm extension from the list. As we need to calibrate the robotic arm in real life, that is, the stage mode, we first need to upload the stage mode firmware to it. Create a script with when Evive starts up as the head block and snap the upload stage mode firmware block below it. Click on the upload code button. Once uploaded successfully, switch back to the stage mode. Now, let's write the script for the calibration. Drag and drop the when flag clicked head block. Next, drag and drop the connect servos block. It will define the PWM pins to which each of these servos are connected. Then, drag and drop the set offset along length block. It will add the offset on the end effector position along the specified length direction and the Z direction. Next, drag and drop the calibrate angles block for calibrating the angles of the servo motor and save them in Evive's memory. Finally, drag and drop the go to XYZ block. It will move the robotic arm end effector to the specified X, Y and Z position in the specified time. Click on the green flag to run the script. If the robotic arm is not straight, then change the base offset angle and run the script. If the rotational servo is not in the center, try changing the rotational angle in the calibrate angles block. Now, let's calibrate the link 1 servo and the link 2 servo. Using a scale, measure the distance of the end effector from the head of the rotational servo to the base center in the Y and Z direction. If it is 200 mm in both directions, then it's okay. Otherwise, change the link 1 and link 2 angles in the calibrate angles block so that the distance is 200 mm along both the axes. If you need to change any angle by more than 25 degrees, then disassemble the robotic arm and carefully reassemble it. Run the script every time you calibrate a part. Let's get the opening and closing value of the gripper. For that, let's write a small script. Drag and drop a when flag clicked head block into the scripting area. To run the code continuously, use the forever block. Set the servo angle to 30 degrees using Evive's firmware. First, using the set servo angle, set the angle of the gripper servo to the value obtained by rotating potentiometer 1. Next, make a variable named gripper angle to save the current angle of the servo. Finally, set the value of the gripper angle variable to the gripper servo angle using the get current servo angle block. Now run the script. Note the value of the gripper open angle and gripper close angle using potentiometer 1. With this, the calibration of the robotic arm is complete. Now we are going to create a script for controlling the robotic arm using the keys of the keyboard. Following are the controls of the robotic arm. When 8 is pressed, the arm should move 10 mm along the x-axis. When 2 is pressed, it should move minus 10 mm along the x-axis. When 4 is pressed, it should move 10 mm along the y-axis. When 6 is pressed, it should move minus 10 mm along the y-axis. When the up arrow key is pressed, it should move 10 mm along the z-axis. When the down arrow key is pressed, it should move minus 10 mm along the z-axis. On pressing the left arrow key, the rotational servo should turn by minus 10 degrees. On pressing the right arrow key, the rotational servo should turn by 10 degrees. On pressing O, the gripper should open, and on pressing C, the gripper should close. Finally, we create the script to initialize the robotic arm when the flag is clicked. With this, the code is ready. Click on the green flag to run the script. Enjoy!
Hey guys! I hope you like this video. Don't forget to share it with your friends and give it a thumbs up. If you have anything that you'd like us to make next, let us know in the comment section below. And for more such exciting DIY projects, subscribe to STEMpedia and follow us on Facebook, Instagram and Twitter. Bye bye!